but I'll be on it always, always and forever.
Hi, welcome to the Pink Chemist. So today we are going to talk about atomic matter. Now, if you are in my class, I highly recommend that you go on Blackboard and pull up the atomic matter PowerPoint. That will greatly help you with going through this lesson. Okay, so I'm going to go ahead and hop right into it because this lesson is a pretty easy one. All right. Now, I do recommend that you also take the initiative to take notes. So while you are listening to me, don't just listen or watch the video. Have your notebook ready and as well as taking your notes and doing the work with me. That will greatly help you on mastering atomic matter. Okay, so there are three parts to an atom, and the three parts are called subatomic particles. So subatomic particles. All right, now the three parts of the subatomic particle, one is your proton, two is your neutron, and three is your electron. Now, in the next few slides, I'm going to go through what the charge is of each of these subatomic particles. Okay, so what is a proton? A proton has a charge of positive 1. It has a positive 1 charge. Now, it's important to note that the charge to a proton is positive. The location of a proton is found in the nucleus. Now, as you can see right here where is a positive charge, right there is our proton. You can also see the information that the mass of our proton is 1.67 times 10 to the negative 27 kilograms. Now, our proton is very similar to a neutron. And I need you to keep note of this. So our proton is very similar to a neutron, okay? And the symbol for our proton is P positive. Okay? Next up, we have a neutron. So what is a neutron? The charge for our neutron is 0, meaning that it is simply neutral. It does not have a charge. This is very important to note because when we go throughout the lessons this year, we will find out the importance of having a neutral atom and then having a non-neutral atom. That does changes things. The location of a neutron is also located in the nucleus. So this is why we say that a proton is very similar to a neutron because they're both located in the same place of an atom. All right. Now the mass of a neutron is 1.67 times 10 to the negative 27 kilograms. Okay. And like we said before, previously when we talked about protons, the neutron is similar to a proton. And the symbol for our neutron will be N. As you can notice, there is no charge, so we did not write one. Next, what is an electron? An electron has a charge of negative 1. It is a negatively charged particle. All right. Now, the location of an electron is located in the electron cloud. Now, as you can see on our image on the right hand corner, you will notice where it's the blue negative charge, how it is located on the outside, the outer ring. That is called our electron cloud. Okay. So that is where we will find our electrons. Okay. Now the mass of an electron is 9.11 times 10 to the negative 31 kilograms. It is also important to note that our electron is much smaller than our protons and neutrons. All right. And our symbol for an electron is E negative. I'll give you some time to write that down. Okay. So this is very important to know. When it comes to discussing what is a neutral atom, a neutral atom is when your electrons and protons attract each other. Okay, so your neutral atom your electrons and protons attract. Okay, and when this happens, this causes for them to come together. So you got a positive. Well, let me do this like this. Sorry, since I got electrons. Okay, so you have a negative for electrons and a positive for protons coming together, making it a zero charge, making it neutral. Now, it's important for us to use positive and negative and not plus or minus, because when we get into learning what our charges do, we will later learn that our negative charges actually means add an electron. And when we see a positive charge, that actually means that we lost an electron. So we'll get into that in our next lesson, but it's important to use the verbiage when it comes to the charges of our atoms, that we use positive and negatively charged and not plus or minus. All right. Now, when you have electrons and you have two negative charges coming together, they're going to repel. They're going to separate. They're not going to come together. They're going to repel. Okay. So a neutral atom is, in short, when there is no charge on the atom. And that's important because that's going to help us to identify what our number of electrons is when we have a neutral atom. So neutral atom means no charge. And when that is the case, that means our number of protons will equal our number of electrons. Okay. Okay, so now let's get into the breakdown of how to identify the atomic number and the atomic mass on the periodic table. So this is where you're going to be able to get your information from of how to identify your number of protons, electrons, neutrons, and so forth. Okay, so when it comes to identifying your atomic number is going to be the number that's located above your element symbol. So for carbon, the atomic number is 6. Okay, and this is your element symbol. Now this is very important to note, okay? Your atomic number is the number located above your element symbol. Now we're going to go to, sorry. Next, we are going to identify the atomic mass. So your atomic mass is the number that is located below your element symbol. This is your atomic mass. All right. So we have identified where our atomic number is located, our element symbol, and our atomic mass. Okay. Now, if you are in my class, we are going to round. Okay. We're going to start off very simple. We are going to round our atomic masses by the nearest whole number. Now, it's important to note for carbon, we have 12.011. We notice that the number behind the decimal, is a 0. So anytime that your number is less than 5 behind the decimal, that means you're going to keep the nearest whole number the same. If the number behind the decimal was 5 or greater, you will actually round up that nearest whole number 1. So in this case, because the number behind the decimal is less than 5, we will keep it at 12. So our atomic mass for carbon will be 12. Okay. Now, when it comes to us identifying our atomic mass, the atomic mass is used as the average of the masses of the naturally occurring isotopes of an element. Okay. We also use the atomic mass to help us to find the number of neutrons in an atom. So we're going to walk through a quick example. Now, we will take carbon, since carbon is the example that we have. In order to find the atomic mass, we will actually use a formula. And the formula that we will use is the atomic mass minus the atomic number. This formula helps us to identify the number of neutrons that's within this atom. So let's try to find the number of neutrons for carbon by using this formula. So my atomic mass, as I can see here, my atomic mass for carbon is 12. I'm going to subtract 12 by my atomic number. My atomic number can be located here, above my element symbol, which is 6. 12 minus 6 is 6, and this is my number of neutrons for carbon. Okay, that was pretty easy, right? All right, so let's go ahead and do an example within a chart. To your right, you will see that we have boron for our first example, okay? So this chart is asking us to identify the atomic symbol, the atomic number, the number of protons, the number of neutrons, the number of electrons, and the atomic mass. Now, I have been given the atomic symbol, which as I can see, it is B. Now it is asking me to identify the atomic number. Now, remember, we discussed that the atomic number is the number that is located above the element symbol. So this is my atomic number for B, which is 5. Okay. Then my number of protons. We also want to note that our number of protons equals the same as our atomic number. So whatever my atomic number is, it also equals my number of protons. So now that I know that my atomic number for boron is 5, I also know that that is the same amount of protons that I have. Your number of protons and your atomic number, it never changes. If you change the number of protons, it changes the atomic number, which then changes the element. Okay, so that is very important to note. Now, because I don't have a charge on any of my element right now, I don't have a charge. I don't have a positive charge. I don't have a negative charge. That lets me know that my element is neutral. And if my element is neutral, that means that my electrons will equal the same amount as my number of protons. So my number of electrons will also be 5. Let me try to write that a little better. So it would be 5. Okay. And then I have to identify my atomic mass. My atomic mass is going to be right here, the number below my element symbol. Okay. And as I can see, I have 10.8. And because the number behind my decimal is greater than 5, I'm going to round my nearest whole number up 1. And so my atomic mass is actually going to be 11. And that's pretty simple, right? This chart already filled in our number of neutrons, but for the sake of helping you to identify and going through a demonstration with you, I will actually show you how we got 6 as our number of neutrons. So remember that when we're trying to find the number of neutrons, the formula is our atomic mass minus our atomic number will give us our number of neutrons. Okay? So this will equal neutron. So our atomic mass for boron is 11. So 11 minus our atomic number, which is 5. Oh, that's an ugly 5. Let me try to write that again. Which is 5. So 11 minus 5 equals 6. And that is how we got the number of neutrons for this element. Alright? So I hope this helped. If you have any questions, please make sure you come to me with your questions and the work shown that you did by following the examples that I did in this video. And until next time, see you later. Bye.
Don't play with it, don't be dishonest. Ay, still not a